in some of the earlier practice videos, we've seen that whenever you natural log something, that approximates to x, and whenever you have this, it approximates to this, and so on here, for when x is near 0. And also we've seen cos of x, and then we've seen sine of x as well, and so on. Well, we can now use this to approximate something that's really complicated. So, for example, let's look at this here. We can use this here to approximate this. So to do this, rewrite this as this here. Rewrite as this. So really, what you've got here is one block multiplying with another block here, and now we can use this to approximate this whole thing here. Okay, so looking at this e here, e to the x is roughly 1 plus x for x equals for x near 0. So we are trying to evaluate this where for x being near to 0. So rewrite this as this thing here, okay, and then use this bit here to turn this block into this. Okay, so looking at this here, so here we've got, looking at this block here, we've got e to the power of minus 7 here. Well, imagine this as being a bubble here. Whenever you have e to the power of a bubble, e to the power of a bubble here, sorry, e to the power of a bubble here, that approximates to 1 plus the bubble itself. So while the bubble itself is minus 7x here. So really this thing here approximates to this when x is near 0. Remember, we are trying to evaluate this near x near 0. We are trying to evaluate this here for x being near to 0. Okay, and then this thing here, for this block here, we would use this here. So this block here becomes this. Okay, so now yeah, so this block here is precisely equal to this, but then the minute we jump from here to here, we would then approximate it. So this thing here becomes an approximation. Okay, so hang on. So from here we would turn it into this, and at the moment this is exactly precisely equal to this. That's why we have to use this equal sign here. But then the minute we move from here to here, then we are approximating. So this equal sign here becomes this approximate sign. Okay, so anyway, this thing here becomes this. So now just tidy this up. Hang on. So tidy this up. Multiply this out. So this times this and this times this. That will then take you to this thing here, and then tidy up. It will then become this, because yeah, merge these two together. That will then give you this, and then yeah. So this whole thing here tidies up to this. Okay, but now we are going. So now at the moment we've got one block. Take away this block, add this block here. The thing is, we are approximating. This thing here approximates to this, but then we can then discard this, because I will explain why later on. We can discard this and just keep it simple, keep it as a straight line here. So at the moment this is our y equals mx plus c in a way. This is our equation of a straight line here. We can discard this. Why? I will explain why later on. But basically, this thing here, we can just keep it simple, keep it as a straight line. At the moment, it's a quadratic. Let's just keep it as a straight line. Discard this bit here, and we will see why later on. Okay. So far, we are trying to understand this here for x being near to 0, and this whole thing here approximates to this. Okay, so now if you get your graph plotter and plot this, hang on, plot the, so this is our complicated function here. This here is our complicated function. This here is this thing here. Okay, So now if you plot if you plot our approximation, which was this here, if you plot the approximation, it will look like this. Hang on. So at the moment, the red graph was our original function. Now plot plot our approximation. It will give you this. See the blue line? The blue line there is our approximation. Remember, our approximation is only good around x being near to 0. So it's only good around here, around x near to 0. So beyond that, it becomes inaccurate. Okay, but the point here is that we can discard this. We can discard this because, hang on, because of this. At the moment, we are trying to evaluate this, and then this approximates to this. Now, the thing is, our approximation is only valid for x being near to 0. If you let x equals, let's say, a random point, let's say 0.07. So when x is 0.07, this thing here approximates to this thing here. Now, when x is 0.07, this thing here is this, and then this thing here is this, and this thing here is this thing here. Well, don't forget, this approximates to this. So this whole thing here is this thing here is already an approximation. So you see, this block here is tiny. This block here is tiny in comparison to this one here. But because this is already an approximation, then this is already tiny. So we can really discard this and just keep it nice and simple. Keep it as a straight line. Because don't forget, this thing here has already incurred some sort of error inside this whole thing here. And when you have x equals 0.07, that equals to this, take away this, plus this thing here. But this thing here is tiny. It's tiny in comparison to this. But because this is already an approximation, then we've already incurred some sort of error in this whole thing here. And then, well, this thing here is going to be tiny in comparison to this. So we can just ignore it and keep it nice and simple. Just keep these two terms here. Okay, so we can just ignore. So at the moment, you've got this block here, take away this block, plus this block here. We discard this because it's going to be tiny in comparison to this. So we can keep things nice and simple by having a straight line rather than a quadratic. Okay.